I guess I will continue in English. Is it okay with you all? Okay, thank you very much. My name is Madjar Moldabayev. I am the GDC lead president of the Google Developer Student Club here at Nazarbayev University. I welcome you all here. To those who came here for the first time, maybe for the second time, or not, who are not the residents of the Astana or not the residents and students of the Nazarbayev University. So I welcome you all, wish you the good and prosperous session here today. Most of our experts here and speakers are beloved experts of the Google, the members of the Google Developers Experts, who are in the counts are really one of the best. So today we could acquire the access of inviting, the opportunity to invite those speakers here to this stage. In the whole world, I guess there are like 10 or 15 Google Developers Experts, and we could invite 5 of them today. So I guess it will be beneficial for you to get some insights, knowledge on various fields. So it might be Google Cloud, machine learning, other aspects, and development fields. So let's actually start our session with one of our beloved expert in the field of the mobile development, Android development specifically. So please welcome Yusuf.
Yeah, hi everyone. Nice to see you all here. Yeah, my name is Yusuf. I'm an Android engineer, and Madjar was lying a bit. Actually, there are not like 10 or 15 experts all over the world. I think there are hundreds of thousands of them, right? But anyways, experts are still very, great specialists.
Of course, in our region.
All right, yeah, let's start with the presentation. So today I'm going to talk about Android component, which is named Android Handler. And this component has been one of the black boxes of Android development for me for a long time, and I think that many people who are doing Android development felt the same. Before we start, could those who have some Android development experience clap your hands? All right. And those who have, in general, software engineering, software development experience, also clap your hand. All right. Thank you. Yeah, and those who have experience with Java or the other JVM technologies, also clap your hand, please. Yeah. All right, awesome. So in general, the audience will probably get what I mean, mostly. So yeah, the agenda is the next. So first we will talk a bit about the threads in JVM. Actually, this presentation is named Android Handler, but surprisingly, we'll talk about Android Handler very little. Like, it will just at the end a bit about it, because in general, in software development, to understand some topic, you don't it's not enough to just know the one concept and what it does, right? You have to know lots of stuff that goes around it, like lots of stuff that communicates with it, that works with it. Yeah. So for this reason, we'll start from a bit far. We'll start from threads in general. Then we'll talk about threads in Android, how threads in Android are different than usual JVM threads, like threads in Java or other JVM languages. And after this, we'll talk about the problems that can happen in Android development while using the Android app, which are specifically app crashes and ANRs. I hope that those who have worked with Android know what ANRs are, and those who don't know Android ANRs, you will learn about it later. And after this, we'll talk a bit about Looper and its role in this equation of these threads, handlers, and everything else. And only after that, at the end, just a little bit about the handler itself. What does it do? How does it help you? So yeah, let's start. Basically, threads in JVM are very similar to threads in other computer technologies. So who doesn't know what are the threads in any programming language or any technology? Who have worked with threads? Yeah, clap your hand if you worked. Yeah, awesome, awesome. Yeah, so next slide. So what is the thread? And again, the next slide. Yeah, in computing, thread is kind of smaller sequence of programmed instruction. So while traditionals run blah, 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 single thread, multi-thread applications are much more performant. And nowadays, most of the applications, most of the programs that we use are multi-threaded. So there are like two types of apps. They may be single-threaded or multi-threaded. Yeah, and benefits of multi-threading is very huge because as we know nowadays, computers can have like very huge resources, right? The phone in your pocket is actually, it is much more powerful than the computers that were used to launch the Apollo shuttle, right? This rocket. Like with the phone in your pockets, you can like potentially launch a spaceship. Yeah, but you're spending its powers to watch TikTok videos. Yeah, shame on you. So basically, having all these resources, it doesn't really make sense if we use only some part of it. So which means single thread. Yeah, it's better if we use everything that this device can provide and create multi-thread applications. So thread is the let's say part of the device's let's say resources. So you may probably heard about the processors, right? The computers can have like multiple processors. They can have like multi-core processors, right? And every core of the computer can have multiple threads as well. So usually threads can be physical threads. Like let's say your computer only has like 8 cores. Its processor has 8 cores, and every core has 2 physical threads. This means that your computer can run 16 threads at a time, right? Because like 2 threads per core and 8 cores, right? This means that if you have any task, let's say that takes some time. Let's say you need to, you're building an application for photo editing, and you have, let's say, 16 photos, right? And editing every photo, like or downloading it, takes like 1 second. So in single-threaded application, this will take 16 seconds because it will take like 1 second per every photo. And in multi-threaded application, if you use the resources of your device smartly, right, your application can do it much faster. So ideally, it can do it like 16 times faster because it has 16 threads, right? And every thread will take just 1 second to edit or do something with the photo. And you can get the final result of 16 photos like ready in 1 second instead of 16 seconds. So this is like basic idea behind threads. So why do you need threads? What can, besides physical threads, like that I mentioned, there are also virtual threads as well. Because nowadays programming technologies and computers are very smart, and they can do like lots of stuff even if they don't have it physically. Yeah. So yeah, next slide. Yeah. So there are single-thread and multi-thread applications, and multi-threading allows you to use the maximum out of your device. But it has problems. Nothing comes just for free, right? Multi-threading creates problems that are usually non-existent while you're just building single-thread application. Like the main problems are the overhead, because again, if you're building a single-thread application, you don't even have to care about threads because you have only one of them, right? Everything will go, let's say, one by one. If you're building the app that edits the photo, first photo will be edited, then the second, then the third, etc. And if you're doing this in parallel, because you're using like multiple threads, you have to handle this as well. You have to make sure that every thread is like working correctly. After it finishes its work, it's like shut down, etc. So there are like additional problems that this can create. And if you don't do it like properly, right, you will have bigger problems. Also, one more problem, the challenge of multithreading is Amdahl's law. It basically says that it actually doesn't really work this way, that if you have like lots of threads, let's say if you have 10 threads, doesn't really mean that your work will be 10 times faster. It works a bit differently. And resource, next slide. Yeah, resource contention is also one of the problems. So yeah, I'll be honest. I don't really know like the third principle myself because this presentation was made by ChatGPT. Yeah, main content, of course. Yeah, some of it. Yeah. So this is the way threads work in computers in Java, in JVM technologies specifically. Yeah. As we know, Android is built upon JVM, right? Java programming language was the first programming language that was used for Android development. And right now, it is mainly Kotlin, but Kotlin is also a JVM language, so it also works on the same principles as Java programming language. But there are some differences, there are some like changes that are made by Android team so that this whole thread schema works for Android. And the main thing that every Android developer should remember about threads in Android, like it's probably the most important rule, right? If you want to just build a hello world application so that it works, you will have to follow this rule. And this rule is that everything that is related to UI, so basically user interface, user experience, everything that is somehow displayed by your application or user can interact with it, it should happen on the Android's main thread. So when you create Android applications, they have one main thread. It's also called UI thread, user interface thread, which is already created by Android, and you can really do much about it. Like you can change this thread, you can shut it down because it is already inside your application. It is like managed by Android, and everything that should somehow change the UI or somehow like interact with UI should be done on this main thread. Like if you're just clicking on the button, if you want to change the text on the screen of your application, etc., it all has to happen on main thread. Yeah, and but it doesn't really mean that you have to do everything on main thread, right? And you actually should not do this because again, threads are also limited. Like every thread has some limits. If you do too much work on the same thread, specifically on the main thread, your application will work worse because its main thread will be blocked by many tasks that it shouldn't have. So heavy tasks that are not directly related to UI work should not be done on main thread because it will freeze your main thread. Right, and this can create additional problems that we kind of had some glimpse at the beginning, which are app crashes and ANRs. So app crash can happen if your application tries to do lots of stuff. No, it's not really like limited by threads. If you do something wrong, like something critical, your app can crash, right? It will stop and users see that it stopped and it will like leave a bad impression and user can delete your application or whatever. Yeah, and there is one more problem, which is ANR. I really like the way one Android developer has explained the problems with this app crash and ANRs. It is main thread imbalance, so overloading or underloading the main thread. So in case of the app crashes, if you underload your main thread, so which means that if you try to do some work that has to be done on main thread, which is works with some tasks with the UI, if you do it somewhere outside of main thread, your app will crash. And if you overload your main thread, if you do something more than it wants to do, some heavy tasks, it will lead to ANRs, which stand for, next slide, app not responding. You probably have seen this, this like error message, error pop-up. I really like that when I try to Google this ANR stuff, like to find some screen of the app stop working, lots of the screenshots were showing that Android itself stopped working, like system UI stopped working. Yeah? It can also happen because Android itself, like the whole system itself, is also like an app that is working all the time. Right? And even Android itself can stop working. It usually happens because the device is like too powerful, right? And its resources are not enough to do like lots of stuff. If you're, for example, playing some game or doing some heavy work, your device itself, your Android itself can stop, right? But mostly it happens with the regular application. For example, Instagram can stop for some reason, right? And this is called app not responding. So like it is not app crash, so app did not die, but it stopped working. Why? Because app is trying to do lots of things that it shouldn't do on main thread. So yeah, so basically the idea is that if you don't work correctly with main thread, you can have such problems as app crashes and ANRs, which are very critical because if your app is too, it's like having these problems too much, if it's crashing too much or it's like stopping working, like not responding like too often, then Android will suggest to remove your app. Yeah, happens all the time, especially when I'm testing my applications and like, you know, during development, there are like usually bugs, right? And I'm testing on my test device, like if it's like happening 2 or 3 times, Android starts to suggest to remove my application, which I'm like building right now. So next thing is that there are some criteria for ANR. So basically, if your app stops responding to user's touch, for example, on some button for 5 seconds or more, then your app gets into app not responding mode. So in this case, Android will show this pop-up that we just seen, and it will say, hey man, like a user, let's call this application because it stopped responding. Also, there is like a rarer case when a component named broadcast receiver stops like responding for more than 10 seconds. But yeah, it will also lead to app not responding. So just not to get to make it too much for now, is everyone with me? Like, are you following along? Like, is it clear, everything? So then clap. Yeah, clap if you can understand everything. Yeah, that's great. Awesome. So yeah, next slide. Basically, there are several ways to avoid ANRs because ANRs, like the main problem that we're trying to solve here with threads. And some of these ways to solve ANR problem are outdated, like async tasks or loaders. Some of them are like modern technologies that we can use right now. It may be RX, Java, or coroutines. But there is also one more component, which is handler, which has been there like all the time from the Android like system's birth till now. Like, I don't know, for almost 20 years, it's been there, and it didn't like, you know, disappear like async task or loaders. It didn't get like deprecated because it is working like under the hood with the whole Android system. So yeah, while async task or loaders were like some temporary solution, right? And over the time when technologies evolved, they were replaced by some more modern technologies. For example, when Kotlin came, we started using handlers, not handlers but coroutines, right? The handler still is there. So before we dig into it, has anyone used handlers or seen handlers while building Android apps? Can you clap your hand? Yeah, not many people. Yeah, surprising. Well, okay, those who had some Android experience, can you clap your hand? Okay, now I see that you had very little experience because if you have some proper Android development, right, if you like build some application, then you bump into handler. Do you really want it or not? You will bump into it. But yeah, so handler is one of the ways to solve ANR problem. So next slide. But before we get into handler, we have to talk about a component named looper. And to understand looper, first we have to understand the way threads work. So the next slide. Yeah, the way threads work is that it's very simple. Thread does some work and it just shuts down after that. So let's say you have some operation, right? And you create a thread to run this operation. You run it, this operation is finished, that's it. Thread just kills itself, it disappears. You can't have it anymore. So, but let's imagine that you need this thread to keep working. Even if it doesn't do anything, it should wait. So do you have any ideas how can you make it wait? Like without killing itself? It's very obvious, I believe. How? But if you make a thread sleep, yeah, if you block it, then it will block, right? Then you can't use it. I mean, yeah, you need it alive, but you also have to be able to use it. So, any ideas? It's like, it's actually, I think it's a bad practice, but there is no way to do it like otherwise. Sorry? Yeah, it actually makes sense. Loaded with little tasks, right? So that it keeps working, right? Even if it's doing something like useless. Yeah, the next slide. So yeah, I don't really like when during the presentations, like, you know, this programmers show code and, you know, try to explain it, because it doesn't really make sense for me, because no one, you know, remembers the code that's shown during some presentation. But unfortunately for this example, I have to show some code. So yeah, next slide. Here, as we can see, like it's a very simple Java application, like which has just one function, main function, right? And it does something. It just prints some text into the terminal, right? As you see in this example, the program is printing all these lines, like program started, blah, blah, doing something, and it finished its work, and it just it shuts down right away. So you can see this message by system that process finished with exit code 0, which means like process finished without any errors, without any problems, right? Because it stopped, like it finished its work. So how can we make it wait at this point? So yeah, instead of now program shuts down and instead of process finished, it should just wait. It shouldn't do anything, right? One way, which I actually found out like not so long ago, it's to make it wait for user's input, right? There is a class named scanner. Next slide. Sorry, it's a video. Yeah, there is a class named scanner in Java, which actually does the same thing. It just waits for user to input. So if you use user input, and if for your program to keep working, you need user's input, then your program will wait for it. So unless user will like type in something, the program will not shut down. So the thread will not shut down. So this is one of the like ways to make it wait. But again, it's also not 100% like silver bullet, right? Because user can enter some data, and after this program will shut down. But you may need the program keep working, right? The thread keep working. For example, user may need to enter the data again, like the second input, the third input. So how can you do it then? Like if you have, let's say, infinite amount of input that needs to be like entered into your application. What do you think? Sorry? While loop, right? So you can create infinite loop, right? So there will be an infinite loop that will wait for user to enter something, right? And isn't this the same principle that Android apps work? So you just open it and you can click it, right? Or do something. And while you don't do anything, it will just wait for you to do something, right? Unless you block the screen. So let's see the example of regular Java application, how it can be done on regular Java application. So yeah, the next slide. So you can do something like this, right? You can use infinite loop, and then inside it, you can wait for a user to enter something. And once a user enters something, the program will not shut down. It will just wait for a user to enter something again. So yeah, let's see the video. How does it work? Yeah, so here your program starts, and you like start typing something. Some commands, let's say 1 stands for this, like 2 for that, blah, blah, blah. And 0 will stand for closing the application. Let's say a back button in Android application, right? So once you click 0, and only then your process will finish, and only then your application will close. This means like in Android app, as you click the back button, right? Or you can click the menu button, and you will, like app will be moved from the task manager to the task manager. Yeah, so this is the way to do it. Just create a while loop, while true, like infinite loop, and inside it, wait for the user input. So let's see the next slide, where we can see, where we can see this line of code that waits for the user input, right? And you wait for user to input something. And the next slide shows the, shows the principle. So basically, the main idea that we just discussed, that we need thread to be alive, right? That it should keep working, is actually implemented by a component named looper in Android system. So looper keeps your thread alive, so it will just hold your thread, yeah? And it also gives it the tasks. So yeah, the next slide. So there is an animation, how does it work? So we have thread, right? And thread is infinitely striving towards ending. It wants to finish itself. So yeah, it wants to finish itself, but there is a component named looper. Next, yeah, which holds it. Yeah, it's holding it, and at the same time, it provides it with tasks. It has component named message queue. it has some work to do, and Looper will provide this work to thread. Like it will give you like, this task, do this and do that, etc. Yeah, next. Yeah, so this is like the rough schema of how do threads and loopers work together. And let's see the next slide. Yeah, the interesting thing is that inside looper, it is like implemented just this way. So this for and semicolon, semicolon means while true. So here you can see that Android team did like exact the same solution that we just came up, right? So yeah, next slide. So looper keeps thread alive and provides it with messages, right? This message can be anything. It can be user clicking something, user like entering some text, or system sending some events. Let's say your battery is draining, right? Or something happening, your like phone is plugged into power charge. So anything that is sent to your application is provided to your, let's say, application's core, which is thread, through component that's named looper. Yeah, but now we are ready to see what is a handler, because now we know threads, we know the looper, and there is one more component that's named thread, and what does it do? Let's see what does it do. Handler is an interface for engineer, for developers, for you coders to run tasks on looper, to send tasks to looper, because you can actually use looper right away, right? But it's not convenient because you have to do lots of steps yourself, like create message queue, put some task to it, then consume it to looper, blah blah blah. Like it's not it's not usable for developers. And for that thing, we need a handler. So for that thing, we are provided with interface that named handler. So let's see the schema. How does it work? We already know like this is the way threads and loopers work, right? And there is the next part of this equation, which is developer. Next, yeah. So developer has to get some access to this process. And for this, developer will use handler, which will interact both with looper and developer. It can like get commands and return some results as well. So, and it will send messages, send tasks to looper. And this task can be of two types. One of them is runnable. Runnable is just an operation without any parameters. It's just like lines of code. If you need lines of code, right, without anything to remember, for example, any arguments, etc., use runnable. And also there is a component named message. Message can be more complicated, like you can have lots of stuff inside messages. So yeah, you can like remember messages as an object itself. So it will be put into the message queue, and then looper will run this operation when like it's time to run it, or when it needs to be run, or it can be run repetitively. So yeah, there are like many use cases. Next slide. Yeah, before we get into use cases, so Android will not let you update UI from background thread, as we already mentioned, right? And for this reason, you will need handler. So using handlers, you can do whatever you want. Like you can have lots of hundreds of background threads, worker threads, when you can run very heavy operations. You can edit photo, you can load data from internet, you can do whatever you want. But when you need to provide some result to your user to show something, like your photo is ready, your file is downloaded, etc., you will have to get access to UI. And for that, you will go to UI using component named handler. And it will run your operation, like showing something, showing the message on main thread. So this is probably the main use case. Yeah, click it. Yeah, this is main use case of handler. Like this is like mostly I've been using handler myself just for that, because I've been doing some work. Actually, at that time, I didn't even understand why it doesn't work, right? I run something on background thread. If I try to update the text from background thread, it crashes. And I just find Stack Overflow answer. It says just run it using handler, right? Handler post, and it will do the work. So yeah, this is the way it works. Yeah. There are actually two functions that you can use to do that. You can do it like directly from handler, but for that you need the handler instance. Or you can use function named run on UI thread. You can get access to this function if you have just access to any view of your application or any activity of it. Yeah, and there are like several smaller use cases for handler, which are scheduling some tasks, so that it works a bit later with some delay. You can also do some repetitive tasks. If you want to like run something like many times, like once in a minute or once in an hour, you can also do it with handler. Next. And once again. You can also change the priorities of tasks. For example, you're like doing this task right now, right? And there are like lots of other tasks that are already in a queue. But you want this to be highest priority. You want it to just be run right away because it's very critical for the application to run it right now. So you can change the order of the tasks to run so that this task can become like highest priority. And also you can cancel tasks. If there is something going on and you don't need it anymore, you can just cancel it using handlers. We're not getting into code for that. You can remember that this is the way it works. So yeah, also there are like some additional components that you can bump into while you're using handlers, which are runnables, which are also messages. So it was already mentioned, like runnable is just a pure function, a pure code, right? Just block of code that does something, and message is a bit more complicated version of that when you can have some parameters, arguments, etc. And there is also one more thing, which is handler thread. Basically, this is a thread that comes with handler like right away. So you don't need to like create a thread yourself, then like associate it with a looper, then like create handler to like bind them together. You just can create handler thread, and it will be all done. But again, in real practice nowadays, no one will do this because we already have like coroutines or Rx Java. So yeah, but this is possible. You still can use this, and it is not like a bad practice and not deprecated. So yeah, handler is still very important. And what's more important than handler itself being important is that you need to know this if you want to be a good Android engineer. Because even though your company will not use it, this is actually one of the issues I have with technical interviews. Even if your company does not use this component, during the technical interview, you'll be asked about it. Because like this is core of the platform, right? Yeah. So yeah, that's it. If you have any questions, we can, yeah, you can ask, or otherwise, yeah, that's it. I actually use this local startup, like QTAP, to generate this QR code. So yeah, you can scan it, and I hope it works.
Cool, cool. Thank you very much for your presentation, Yusuf. For those guys who will ask interesting questions, we prepared some stickers. So if you want to receive like some stickers related to the Google technologies and etc., then you can ask interesting questions to Yusuf.
Yeah, sure. Once more.
Why, when we underload the main thread,
Yeah. I get it. Yeah, underloading the main thread. Yeah, the question was why underloading main thread can lead to app crash. Because it's actually a good question. Because I think my phrasing was not was really clear. The point underloading is that you are taking the work that has to be done on main thread and you're doing it somewhere else. So what is the work that has to be done on main thread? Yep, exactly. Work with UI has to be done on main thread. And if you do it on some other thread, like background thread, worker thread, app will crash. That's the idea under underloading. So you're taking some work from main thread. Because Android will crash it. It's just, let's say, security trigger of Android itself, like security mechanism. Like if Android will see that you're trying to update the UI from non-main thread, right? It will crash your app. Even though I think it can do it, but it will not let you do it. It's just the system that's built this way. Yeah, they have this if-else statement, like if thread equals to main, okay, else, just throw exception. This is the way it works. It's actually a good question because while preparing for this presentation, I was thinking the same thing. Like I was trying to, I asked ChatGPT like a question, can I hack the system and make Android run UI tasks on different thread? But I think it triggered hack word, like hacking word, and it said I can answer this question. Yeah. But yeah, in reality, it's not possible to run anything UI related on like threads other than main. Actually, like there is one more thing that's like prohibited by Android, but it's possible, is running network operations, like going to internet and grabbing something, like loading some data. Right now, if you do this, like if you are trying to load some data from internet on main thread, your app will crash. But you can override this rule. Like on Android Studio, you can like turn it off so that Android will not check this network on main thread exception, and it will let you do it. But unfortunately for UI, it's not possible. Yeah, great question, by the way. Yeah, thank you.
Yeah, please distribute the sticker for the person who asked the question. Who has the question can get the microphone and ask it.
All right, thank you first of all for your presentation. I have a question about this. Like, I don't have experience in Android. I'm just curious. Like, if we open the mobile app, for example, main thread it starts working, yeah? And when we close, main thread is also ended. Am I right? And how the waiting in of the mobile app? So when we just weld the mobile app without like fully exiting, and they're just waiting for us. But they're doing something background activity. How's it?
Yeah, awesome, great question again. Like I'll say it again. Like yesterday we had the talk with students from Nazarbayev. Are you from Nazarbayev University?
Yes.
Yeah, we had like the dinner with organizers, and like we talked a lot about like programming career, and like they were asking very smart questions. And today again, you're also asking very smart questions. Like thank you for that. Basically, you have a correct idea. Like how does it work? There is a component, like not a component, but a, let's say, a thing called process, right? We have processor, and everything that runs on processor is a process, right? When you open the application, Android will create a process for it, right? And Android can actually create lots of processor for application. For example, your application can have, let's say, a background service. Let's say you open the app and you start loading some data. Let's say you opened Instagram application and you uploaded a, I don't know, 10 minutes long story, right? And it can happen in a single second, right? Instagram will do it for 30 seconds, right? And during these 30 seconds, you still can use the application. It doesn't block. It will not wait for the video to be uploaded. Why does it happen? Because there is a component named service, like background service, which is responsible for that. And even if you close the application, it will keep working. Even if you like remove the application from Task Manager, I believe, it will keep uploading the story till the end, right? Unless you cancel it manually inside the application, it will try to upload it all the time. This happens because your application, as you mentioned, like you removed it from the Task Manager, or if you don't remove it, this service will keep working in different thread. Because Instagram, as an example application, will have two processes. One for UI that you can see, and one process will be created once you start uploading. So in case if your application is closed and the some like operation should be like continued, the developers they create extra background task and they put it in extra process. And this process can have like very high priority, and it will not be like closed when you remove the application from the Task Manager. Yeah, so this way you can keep your thread working. And also, like even if you put the app in this suspend mode, when you just open another application, its process does not get killed right away. It will get killed only like if there are too many applications working except for it, and like it has very low priority. And in this case, the system will close its process because it needs some resources, and in this case, its thread will be killed and created again. If you open it like before its process killed, you will open the same thread that was there. Yep, you're welcome.
And another one, and the background services, is it like the same? When application sends, for example, message or other things when you close, and if it's like offline mobile, for example, games, and they send you a message after some time, is it like work also on the background service?
Yeah, definitely. So you can just check that manually by doing what? You can try to do some operation, and if this operation will stop when you close the application, it's not in background thread. For example, if you're using music application, right, music player, and if you're like listening for music, and if you remove the application from Task Manager and it gets killed, it means that it's not in background thread, like background process. And it's actually what happens on Xiaomi devices, right? In Xiaomi device, if you remove the even like player application from the Task Manager, it will like stop your music, which like sucks actually. but this is the way they do it to like limit resources. So yeah, this is the way it works.
So does anyone have extra questions?
Hello, my name is Sultan, and my question is,
Man, you type on the...
Oh,
Yeah, sorry, keep going.
we already know that JVM has own physical threads, and we also know that our language has virtual threads. And I want to know how they interact with each other.
Yeah. So yeah, actually interacting between threads is also a very huge topic, and it's actually one of the probably most complicated things that can be inside the application, right? And there are tons of ways to do this. So the most obvious thing, like if you can imagine like the code, right? What do? You create a thread, right? You create the second thread, third thread, etc. So after this, you have to communicate between them, and there is a standard mechanism of Java that's named join, thread join. You can just join all these threads, but again, you have to manage them manually because you just have a bunch of them, right? They're somehow related to each other. They know that they exist, right? But they're not like, in this tight couple. They don't really depend on each other. They will not wait for each other, for example. So if you have a task that the task on this thread should only happen after the task on another thread finishes, this will be very hard to implement. This again, it has to be done manually. For that reason, on Java itself, there are such components as thread pools and executor service, which actually does this manually instead of you, automatically. So you can use these components and it will do this for you. So you can just write it down as well. You took notes, so it's a great practice actually. So yeah, executor service and thread pools are the way to do it on Java. Probably there are newer ways as well in Java, in newer Java versions. I don't really know that right now because I'm not really using Java. But yeah, this is the way to do it. And on Android, you've seen that slide, right? The way to manage ANRs. So these 5 ways can actually be this answer to your question. So you can use async task or loaders, which are very old way to do it. So I don't really recommend it to do that way. Or you can use Rx Java and coroutines. So this is the more modern ways to do this. And also you can use handlers. Again, handler will be a bit bulky. So yeah, usually Android developers will use Rx Java or Kotlin coroutines for this.
Yeah, I guess that's it for the Q&A session. Sorry, guys. We have some extra speakers who will provide also their presentations. Let's give extra round of applause to the Yusuf for really insightful presentation about Android.
Next.